In this lesson, we are going to be applying the knowledge that we have about the vertex form of a quadratic function to different problem-solving scenarios. In problem number 1, it says predict which of the following functions have a maximum value and which have a minimum value, and also predict the number of x-intercepts for each function. If you have knowledge of vertex form, this will be no problem, and it might be helpful to visualize these problems. So if we look at this first question, what we know is that it opens up because the coefficient is positive, and we know the vertex is at -3, that's the opposite of +3, and -4. So your vertex would be at -3, -4, so somewhere here. Okay, so -3 and -4, that's our vertex, and we know that it opens up. So what that tells us is a few things. It tells us that this vertex is a minimum. It's on the bottom of the function, so it's a minimum. And it also tells us that we would have 2 x-intercepts. So let's just apply that knowledge to a few more questions. In the next one, we know it opens down, and we know the vertex would be at +5, the opposite of -5, and -2. So +5, -2 is roughly here. So that would be +5 and -2. And we know that it opens down, so it would look something like this. That tells us that the vertex is on the top, which is a maximum because it opens down, and also that there are no x-intercepts, so no x-intercepts. And in the last question, let's go ahead and do this one. We know it opens down. We also know that the vertex would be at -6 and 0. So your vertex would be at right roughly here. This is the point roughly, -6 to the left of the x of the origin, and 0, which is right on the x-axis, and it opens down. So in this case, the vertex falls right on the x-axis, so it's a maximum. And because it's exactly on the x-axis, we have exactly 1 x-intercept. In the next problem, we're going to be looking at a word problem. So the word problem states this. A soccer ball is kicked from the ground. After 2 seconds, the ball reaches its maximum height of 20 meters. It lands on the ground at 4 seconds. Determine the specific quadratic function in vertex form that models the height of a kick. So what we know is that we've got a kick that does something like this. It starts at the point 0, 0. It lands at the point 4, 0. And in the middle, which is at 2 seconds, exactly between 0 and 4 seconds, we have a maximum height of 20. So the useful thing to understand is that because we're in vertex form, we would like to use the vertex. With your vertex being 2 and 20, we know the following information. We know that it's y is equal to a, so based on the vertex, y is equal to a times x, that's the opposite of +2, which is -2, squared, and then plus 20. So that's useful information. Now to determine the value of a, we know this is a quadratic function that opens down, so we know it's a negative value for the coefficient a, but we don't know the exact value. To do that, we are going to substitute one of these points that I'm highlighting in blue into the function, which we've done in a previous lesson. I'm going to go ahead and substitute the point 0, 0 for x and y into here, and it's to determine the value of a. Okay, so y, which is 0, is equal to a times x, which is 0, minus 2 squared plus 20. So 0 is equal to a times -2 squared plus 20. -2 squared is +4. -2 times -2 is +4a plus 20. The opposite of adding, we're just going to solve for a, is subtracting 20. So your -20 is equal to 4a. Then we can divide by the coefficient 4. To get a is equal to -20 over 4, which reduces or simplifies to 5. So if we put all of these things together, you will have that y is equal to -5, that's your coefficient a, times x minus 2, because the x-coordinate of the vertex is +2, squared, plus 20. The next part of the question says, state the domain and range of the function. Because it's a word problem, your domain is restricted to being between, and I'll look at this in orange, between 0 and 4. Your domain stops at 4. So your domain, lots of ways you can write it. You could write it like this, between and including 0 and 4, or you could write it like this, a set notation, between 0 and 4. Your range in this case is between 0, which is the ground, and the highest height, which is 20. So your range is between the ground and 20. Or you could write it like this. Okay? The last part of this question is part C, which says, when was the height of the ball, or what was the height of the ball at 0.5 seconds? So essentially, if what you do is look at what I have in purple here, we know that at 0.5 seconds, which is roughly here, we don't know the height. Okay? So if we substitute x is equal to 0.5 into the function that we know it is, we will get the height at that particular time. So it would be y is equal to negative 5 times 0.5 minus 2 squared plus 20. Zero 0.5 minus 2 is negative 1.5. Negative 1.5 squared is 2.25. Next, negative 5 times 2.25. 2.25 times negative 5 is equivalent to negative 11.25. And if we add 20 to that, we would get a height of 8.75 meters. That's our answer to this question. The next part of the question says, when was the ball at the same height on the way down? So for this, we're going to use symmetry. So if we know at 0.5 seconds the height was 8.75 meters, then we should also know, so that's 0.5 seconds from when it left, we should also know that 0.5 seconds before it landed, based on symmetry, it would be at the exact same height. So if I go backwards 0.5 seconds, that would give me 4 minus half a second, which is 3.5 seconds. So at 3.5 seconds, we had the exact same height. So the answer to this question is 4 minus a half, which is 3.5 seconds. So the last part of this lesson is just the key ideas, which you may want to pause, I will talk through them quickly, of the vertex form of a quadratic function. The key ideas are as follows. The vertex form of a quadratic function is y is equal to a times x minus h squared plus k. The vertex, the characteristics are the following. The vertex of the parabola has coordinates opposite of h and same as k. So the opposite of h is the x-coordinate of the vertex, same as k is the y-coordinate of the vertex. Or if you look at the following example, if we have x plus 2 squared in brackets, it would have negative 2 as your x-coordinate and positive 3 as your y-coordinate. That would be your vertex of this one. And for the following question, would have a vertex of the opposite of negative 2, which is positive 2, and 3. Characteristic 2, if a is greater than 0 or positive, the parabola opens up. If a is less than 0, the parabola opens down. And a couple more things. To determine the vertex form of a specific quadratic function, you must know the following. The location of the vertex. This helps determine the values for h and k. And the location of another point, which helps you determine the value of the coefficient a. A quadratic function may have 0, 1, or 2 x-intercepts, as we learned in this lesson. You might want to sketch a graph to help you determine the number of x-intercepts. And finally, to solve problems, it often helps to do the following. First of all, draw a diagram of the problem. And second of all, determine the vertex form of the specific parabola. Then you may have to substitute, just like we did with the soccer ball problem, a value into the function to solve some sort of question.